Yeah, good morning. Indeed, we discussed about the voice over internet protocol in the last discussion, wherein I think we have discussed in detail about the internet protocol that's being adopted for the voice communication over telephonic network. Today, we'll discuss the certain protocols that are really very helpful for the purpose of transmitting the multimedia applications through the network. I think a few of the protocols are inherently we discussed with the discussion of the earlier topics. But however, there are a few more protocols that are very important for communication of multimedia, and they will be supporting the transport layer protocols like UDP and TCP. And hence we need to discuss about those protocols. One such a protocol is the RTP. Just a minute. Yeah. Right. The RTP is basically called as the real-time transport protocol, which is being used with respect to the multimedia communication in most of the real-time applications, because real-time applications are the applications where the transmission and receptions are happening simultaneously, and also at the same time there will be management of the session to happen very effectively. In order to manage the session, we'll be using the session initiation protocol. It is called as SIP. This again, SIP will take care of the complete handling of the session, because once the multimedia communication starts, since from the beginning to the end, there should be a control over the session, so that whatever the packets or data chunks are going to be transmitted from source to destination should be delivered appropriately in time, so that the receiver can receive it and can play back it at a proper time. All this is possible only when you have a capability of handling the session in an effective way. So in this regard, we'll discuss these two protocols. So first, let me go with the real-time transport protocol, which is abbreviated as RTP here. Okay, I think it is the very popular type of protocol, because this protocol is being used for all real-time applications. Basically, it is used in association with the UDP, and most oftenly we call it as the RTP will run over the UDP. What is UDP? UDP is User Datagram Protocol, and we know that it is a non-reliable communication protocol at the transport layer. And this UDP is more or less popular to be adopted in the case of real-time applications like audio and video. Now we'll discuss the basics of the real-time transport protocol, and then we'll discuss about the structure of RTP and its header and the body. Here you can see this, the RTP specifies the packet structure for packet carrying the audio video data. Basically, the job of an RTP is to see that it will be encapsulating the data of audio and video in the form of chunks, and these chunks will be added with certain header information, and then it would be forwarded to the next level. And believe it or not, the RTP takes care of the packet from end-to-end transmission, and hence it plays a very important role in defining the various segments of the RTP in the packet structure. You can see that the RTP is referred by the RFC 3550. What is RFC? It is more oftenly called as request for comment. Request for comment. I think the viewers can definitely go for this. If you Google RFC 3550, you will get complete detail of the RTP, because the 3550 is specifically meant for the RTP. Any request for comment is the standard design that has been proposed over the particular protocol, and the complete structure of the protocol, the operational features, and all the standards of RTP, everything is defined in this RFC. So that's why you can participate in RFC, and you can be a reader of RFC, even to an extent that you can give some suggestions on RFC so that it can be adopted in later days. Again, there will be reviews done over that, and if it is acceptable, then it will be accepted and updated in the RFC. Now, let us understand what exactly is provided in the RTP packet. RTP packet is basically will be having the payload first. It will be indicating the payload type in the packet. What is the payload type? It will explain you what is the different type of the encoding that is being done, because you know there are different types of encoding that are possible for real-time applications like audio and video. There are some examples like I can say G.711, G.726. Okay. Likewise, you have different standards of encoding. Even you can talk about the GSM is another standard of encoding. If it these are all for audio only. When it comes to the video encoding, you can understand that 263 H.263 is there, and H.264 is also there. Okay, and you believe it or not, the most popular one is MPEG 1, or you can use the MPEG 2. All these are all called the encoders. So the payload type will indicate these encoders in an effective way. Then comes the packet sequence numbering. I think you know that whenever any real-time application run over the internet, the order of the packets that have been received at the receiving point may be may not be in the proper order. It is because of the UDP's basic nature. UDP will try to push the packet through the network to the destination. Sometimes the later transmitted packet may be received early, and early transmitted packet may be received later. So with the help of sequence number, the receiver could able to reorder it and play back the video or audio. Then comes the time stamping. I think you know that the time stamping and the sequence number both will serve a similar kind of responsibility, but time stamping is very essential in case of the audio and video, because every chunk will be added with a time stamping, calculated time stamping. It all depends on the sampling what is developed in at the sender point, so that these samples will decide the chunks, and these chunks will be added with a timestamp. Then we'll discuss about the RTP runs in end system. You remember this point. It's very important. Only at two ends. Okay, the RTP will run. It will not run in between the network. Okay, only at the end systems you can see the RTP to run. So that we say at the transport layer, it is an end-to-end communication, and hence RTP is meant for the end-to-end communication. RTP packets encapsulated in UDP segment. It's very clearly told in the beginning that RTP is placed over the UDP. Obviously, the RTP is embedded inside the UDP segment. Okay, so I think I will explain it in detail. You can just see the view of this one, the appearance of this one. The RTP is like this, and this is the UDP. So encapsulation of RTP in UDP packet is done, and hence it is written so. Then an interoperability is also possible. If two voice over internet protocol applications run the RTP, they may be able to work together. It means that they might be working with different applications, but they could able to run up between the RTPs. Let us discuss on to the RTP in detail. Now you can see that the RTP runs over the UDP. This is a very basic component to understand because RTP works at the transport layer, and more or less UDP is also in the transport layer. Then the question is how the RTP supports UDP, or how the RTP is different from UDP. RTP is basically to establish the connectivity between the sender and receiver, and try to organize the packets in such a way that it is being delivered to the destination, so that they can use the data that is being delivered to the destination in an appropriate way without any confusions. So you can see that RTP library will provide the transport layer interface with an extended UDP. So it will provide the port numbers and IP address. And it is very clear that at the transport layer we use the address that is called port address. Whereas when in case of application layer we use the specific address. Okay, and in case of network layer we use the IP address, or logical address it is called more oftenly. And if when it comes to the physical layer, it will be called as either a physical address or MAC address. So likewise, different addressing schemes are there. Since it is working at the transport layer, the address that is being used here is the port address. And in support to that one, IP address will be added to it at the network layer point. Then the payload type identification is very essential. I think I told you the payload identification is nothing but the what we say the type of the encoding. Okay, encoding type is indicated. Then the packet sequence numbering, it is for the purpose of ordering the packets that are being received. Time stamping. This is very important in order to make the playback at the receiving point, and there are certain decisions are taken at this point. I'll tell you, there is a slight hairline difference between the sequence number and the time stamping. Both looks to be the similar at the receiving point, but there is a small difference between them. That is, time stamping is used to take a decision that whether the given packet or received packet to be played at a particular sequence or not. Because There are possibilities. Sometimes this whatever the time stamping says that it is already delayed too much, and hence it may not be used to playback. Okay. Suppose you assume that the fifth word in the sentence is supposed to be reach at particular point before the delivery of fifth word, but it has been reached after the sixth word delivery. Then there is no point in delivering the fifth word. So the time stamping will give such information, and that will be helpful. Now, let us discuss an example over the RTP. The sending 64 kbps of PCM encoded voice over RTP. PCM is pulse code modulation. I told you the type of the payload is indicated as whether it is the PCM or something. And application collects the encoded data chunk in every 20 millisecond. You know, the every 20 millisecond means it is the sampling rate we say. What we say is sampling rate. Whenever we do encoding, the sampling is the first process that takes. So the duration of sampling is taken as 20 millisecond here, and during this 20 millisecond, depending on the data type and the speed of the data, we say that it will take about 160 bytes in one sample, and hence we say this is the chunk that has been developed out of this sample. Okay, this will be encoded, and always this sample is the actual data chunk, and this data chunk is added with an header. Okay, let us call this as the chunk. This chunk is added with an header. What is this? This is an RTP packet. Okay, it will be having the payload. Payload is nothing but chunk and the header, and hence it is forming the audio packet there. You can see this. The chunk plus RTP header form the RTP packet, and further it is being encapsulated in the UDP packet. And this is called UDP header. This is added with the UDP header. So whenever this is being forwarded in the network, it will go as an UDP datagram. And when it is received at the end point, at the receiver point, it will be extracted the RTP out of UDP, and it will read the header, wherein the time stamping, the sequence number, and payload type, everything is read. With that help, it could able to read the data in it. That is, the chunk will have the audio information that can be read according to the information that has been provided in the header. Right. Then the RTP header indicates the type of audio encoding in each packet. That's what I told you. And the sender can change the encoding during the conference. This is one exceptional case that can happen. There are possibility that the first few minutes the PCM encoding is done, and next few minutes G.711 encoding might have been transmitted. But anyway, since it has been indicated in the header, the receiver can update it accordingly and can play back according to the standard of payload. Then the RTP header also contains the sequence number and also the timestamp. As I told you, I discussed the significance of the sequence number and the timestamp. Here, one thing to remember is RTP does not provide any mechanism to ensure the timely data delivery, or what we say, the quality of service guarantees. RTP is not meant for that. RTP's responsibility is a safe transfer of the transfer of data in such a way that it has been encoded at the source point, and it will be decoded properly at the receiving point, and the reading of data is very proper. That is the basic idea in this, because real-time applications are run on real-time process, and the timing is very important in this case. The timestamp, the payload, all that will give an idea how exactly it is being encoded. So the decoding process will be done in an appropriate way and in a quick manner. Reordering of packets is possible. Uh, on the basis of time stamping, it will take the receiver will take a decision whether to accept the packet for the playback, or it has to be ignored. All that will be decided by the RTP, but it is not ensure you any quality of service. Quality of service means the data delivery responsibility, because UDP will take the responsibility of data delivery. And UDP, more or less, it will be using the best effort service, because RTP is encapsulated in UDP, and the best effort service is taken by the UDP. And this best effort service, which I already discussed earlier, it says that it will try to reach the destination at the earliest, irrespective of the loss or the packet error that could have been occurred in the path. So it may not be using the single path, it may be using the different paths, but ultimately it will try to push the packet to the destination at the earliest. That's the idea in this, and hence you cannot expect any level of service guarantee. Okay, so if you have transmitted 100 packets, you may end up with receiving 80 packets, or sometimes 90 packets, sometimes 70 packets, but no guarantee that out of 100 are received or 90 are received. Okay, no as such guarantee is provided by this, because the very nature of UDP is to say it is unreliable, but it will try to push the packets at the earliest to the destination with the support of the best effort service. Let us make an analysis of the header of RTP. You can see that this is the structure of RTP header, which has got the payload type, the sequence number, the timestamp, and also SSRC, synchronization source ID. It is called synchronization source ID. Okay, and some miscellaneous fields are there which are used for the future requirement, which are reserved for the future requirement. You can see that. Let us go with one by one. The first one is the payload type. Okay, so this payload type, as I mentioned, it is used for the purpose of indicating the type of encoding. There are 7 bits used for this. How many bits? 7 bits. Okay, these 7 bit will represent the values like 0, 3, 7, 26, 31, and 33. And what each value indicate? If it is 0, it means that all the 7 bits are 0. Then the value is 0 in this payload type, and which in turn indicate the source is using the encoding technique of pulse code modulation, mu law, with a capacity, or with a generation data bit rate generation of 64 kilobits per second. This is what the indication of this one. The second one is, if it is 3, then it is indicating that encoding is GSM, and it is developing the data at the rate of 13 kbps. For 7, LPC with 2.4 kilobits per second. With 31, it is S.261 is the encoding, which is used for the purpose of video. Okay, like this, you can identify the type of the payload by means of the value that has been represented in this particular segment, that is payload type. Then comes the sequence number. The sequence number is one and very essential component of any such packet communication. The reason is, uh, especially in case of UDP, the datagram transmission will not be reliable, and it will be using different path to reach the destination. There might be, suppose I might have transmitted the packets in this order, 1, 2, 3, 4, 5, but it might have received like this. Okay, so you see the disorder of the reception of this packet. So this disorder can be overcome by means of sequence number, because the sequence number is telling it is one. It is not 1, 2, 3. It is 2, 3, 1, 5, 4. Now it is very easy to reorder these packets and utilize it in a proper sequence. So this sequence number requires 16 bits. So how many bits are required? 16 bits are required. Okay, and it will increment by 1 for each RTP packet. Obviously, the first packet might be 1, second is incremented by 1, third is incremented by 1, fourth is again like that. Okay, it will detect the loss and restoring of the packet sequence. Whenever a loss of a particular packet happens, that can be identified. Suppose 2 is not at all received. Okay, 1, 3, 4, 5 are received. Then you can easily identify 2 was missing. So that you can ask the sender to retransmit the 2. They will retransmit the 2, and hence it can be restored back at the receiving point. Then comes the timestamp field. I think it is the third segment in it. The timestamp is 32 bit in length. This is 16 bit. This is 7 bit. Okay. Here you can see that the 32 bit long timestamp has got a very good relevance to use with the RTP, especially in real-time applications, because this timestamp will help the application at the receiving point to play it back appropriately, and also it will be helping to take decision that whether it is to be played back or to be discarded, depending on the expiry of the timestamp. Now the question is, how do you exactly decide the timestamp? The timestamp is decided by means of sampling period. Okay, as I was mentioned you earlier, the encoding first step is sampling. That there is a big data to be transmitted or an audio file to be transmitted. It has been sampled like this. Okay, so it is broken into smaller parts, and this sample is prepared. So the sample will prepared with a particular duration. It might have taken different duration with the different encoding techniques. It all depends on the encoding technique. That's why the payload will indicate the encoding type, so that on that basis it will decide, the receiver can understand what is the speed or the sampling time. 125 microsecond is the example here. With this, the sampling rate is 8 kilohertz. 8 kilohertz means 8,000 cycles per second. Okay, so these many samples can be taken. Okay, this is the sampling rate. So on this basis, we can identify this is the first sample, the second one is second sample. The time stamping is given on this basis. 1 by 8 kilohertz will give you 125 microsecond. Yes or no? Yes. So this is a way you can identify the time stamping, and that will be very much helpful for the receiver to use it. Now we'll discuss another one more an important component in this, that is called the synchronous source identifier field. Again, it is of 32 bit in length, and of course you can see that this will identify the source RTP stream, because always it is essential you to identify the source address. It is addressed through the synchronous source ID. Okay, it is abbreviated as SS RCE. Okay, this will distinct the different communication, because there are possibilities where multicasting is possible. Okay, whenever you do multicasting, you have to distinguish the different sources. Okay, source 1, source 2, source 3, like that. So this is possible with the help of SSRC. So that is the basic purpose of this SSRC. Right, I think this is all about we can discuss on the RTP. I think you can understand the RTP as the basically it is a real-time transport protocol which is used in association with the UDP. It is basically used for the purpose of delivering the packet in a proper with a proper information. The informations like encoding type, the sequence number, time stamping, and source synchronization address. All these are very important, and hence it's being used along with the UDP. Yes, there is another important protocol that is called session initiation protocol. This protocol is again plays a very important role because basically it will do activities like it will initiate the session, it will manage the session, and it will terminate the session. So these three responsibilities are handled by the session initiation protocol. You know, the RTP is contemporary. It is not exactly the same activity, but in association with RTP, SIP is used because SIP's role in handling the or managing the session is possible. It will initiate the session. Once it is initiated, then there might be a lot of operations may take place in the session continuation. For example, manage session means you may pause for a while. You are reading an audio, and in between you may pause, or suddenly you may go to stop, or sometimes you may ask to forward. You may feel like rewind. All these things are taken care by the manage operation of the SIP protocol. Then finally, if you totally close the application or the communication of this particular file, that can be done through this termination. Basically, it will be using the signaling and termination, and you believe it or not, SIP will use more or less most of the components of HTTP or SMTP. It resembles many components of these two techniques. That is hypertext transfer protocol, simple mail transfer protocol. Here, all telephone calls and video conference call can take over the internet. That is the idea in this. You can, because of that reason, session protocol is essential. Then people identify the names or email addresses rather than phone numbers. We call it as mnemonic address. So address by means of mnemonic is very essential because the high level address can only be understood by the people. Okay, so that's why that's being used by this SIP. Then can reach the callee no matter where callee roams, no matter what IP device the person is using. It means that roaming device can also be approached. Okay, and also their type of device is immatter. So even for different type of device also it can be handled very perfectly. So that is why SIP is very essential. As I mentioned in the previous discussion of the RTP, here also RFC plays a very important role. RFC stands for request for comment. 3261 is meant for that one. Okay, if you want any detail of the SIP, you please go refer the RFC 3261. Even if you Google it, you will find the details of this RFC, and you can understand or read much of the information regarding the RFC. Let us discuss a few of the services that are offered by the SIP. SIP provides the mechanism for call setup. Basically, I told you initiation of the session is possible. Call setup is meant for the initiation of the session. For caller to let the callee know she wants to establish a call. It means that a request should go to request or an invitation. We say invitation. Okay, should go to the callee. Okay, so caller and callee can agree a media type encoding. Okay, so mutual acceptance is required. That is done through this one. Okay, then once mutual acceptance comes, then the transfer of data happens. Then finally they can stop their communication by ending the call. Okay, so initiate, invite, mutual acceptance, transfer of data, and then stop it. Okay, all these operations are taken care by the SIP. For this, it will determine the current IP address of the callee. In order to identify the callee, it has to search for the IP address. How it will map the IP address from the mnemonic to the IP address? It is just like performing the operation of DNS, domain name system. We know that in the domain name system, it resolves the IP addresses. Then it will manage the call also. This is another an important service provided by the SIP. It will add new media streams during the call. Okay, it means that you can add any new requests, and you can give the support to them. Then there is a possibility of change in the encoding technique. Suddenly it may change from PCM to G711. That is also handled. It may invite others to the communication, because I told you multicasting is possible. Okay, more than one or two people. Okay, so that conference call is possible. Now you can understand. You are using the conference call with the telephone, no? Right now in the mobile, it is all because of SIP. SIP plays a key role in making the conference call. And there are occasions wherein you transfer call in your mobile from your number to the another number, because you may not be at the current number is at home. Okay, you are at office now. This call is transferred to office from home number to the office number automatically. Or there might be a chance that you, in between the discussion, you are trying to listen to the other person in front of you. So you will hold the call for some time. Okay, so that is also possible. All these operations are called call management. Okay, you know, the call management will help. It will create a lot of features that are very handy for the user. Because of this, the user is really enjoying the operations of the telephonic calls. I think nowadays with mobile, we will be using all these features in an effective way. Let us understand a few more aspects of the SIP, practically how it works. It has been explained with the support of an example here. You can see, as I told you, there are three basic things that are performed by SIP. One is initiation of the call, then managing the call, and third one is termination. You see here in the beginning a request goes to the callee. What is the operation performed here? An invitation from Alice to Bob goes. Okay, we know only the Bob address in terms of mnemonics that will be converted into IP address. You see the IP address. Okay, it's been converted. Who is the caller? Caller is this. His address is also identified. Okay, and then it is forwarded as the type of the media is audio, and also it has given the versions of RTP, and also it will tell you to which port it should approach at the callee point 5060. It is the SIP port at the receiving end. Okay, so now you understand how it will initiate the call. Alice wants to connect with Bob. It will send an invitation by typing invite, and the address of Bob is written in terms of mnemonic because he doesn't really know the IP address of Bob. So mnemonic is given. The mnemonic is being converted into IP address. A resolution is done in the SIP, just like in DNS. Then it will forward that request to the Bob by adding so many other features like what is the encoding technique and what is the version of RTP, all that will be indicated, and to which port it is supposed to be approached, that is also indicated, so that directly it reaches the Bob. And once it is reached the Bob, it is responsibility of Bob to respond to it, because the response of Bob will help in understanding Alice whether he is interested with my communication or not. So that is why he is replied with an acknowledgement 200. Okay. The 200 will indicate the port number, his port number and IP address. Also, it will tell is accepting for the communication. Okay, right? Then with this, it will reach the port 5060 at Alice. Once this response comes, then an acknowledgement goes from Alice to Bob also saying that, yeah, we'll start the communication. Then you can see communication started. Bob has sent something with some encoding, micro law audio. When Alice is responding with different encoding, you believe it or not, the encoding technique can be changed. That is what is the beauty of SIP. Okay, the different encodings are accepted at different point of communication. Once the communication is over, there will be a request for termination, and hence the termination of connection takes place. So all the three we identified. Initiation we identified, then management and data transfer, finally termination. So all these three processes are happened, and you believe it or not, SIP will be using an UDP or TCP with their support, and also it will be sent over RTP and UDP. You remember one thing, RTP is complementary with the SIP, and also it will run over the UDP. So this is how exactly the communication takes place between the sender and receiver. Now setting up a call, I think in detail we'll discuss. I think already I have told you, but anyway, once again, you see that the codec make the negotiation about the encoding technique. Okay, so Bob might be interested in PCM technique. Okay, so it will send an acceptance reply by the Bob listening to the Alice, and Alice can send a invite message for advertising and advertising the different encoding technique. That is also possible. Alice is not interested in PCM. She may offer GSM. Okay, so that is also possible. Even rejecting call is also possible. Bob might be busy at this point, and he is not really interested to make the communication with allies, he can send a rejection. And also the media can be sent over RTP and other protocol. I think already I have told you. I think you can see the complete structure of the program segment with the machines. Machine can understand only program steps. You can see the invite process via SIP or SIP is the protocol version of protocol. It is run above UDP. The IP address is this one. The from address in mnemonic, to address in mnemonic. The call ID has generated. The what is the type of the content, length of the content is indicated, and here are the other information with respect to the encoding and the communication. This is all happening exactly in case of the SIP, and machine will work with these commands and statements so that the message of one machine can be understood by the other machine. Here, more or less, it will work just like an HTTP message syntax. Next, the possibilities name translation and also user location identification. There is a possibility that name translation is required because I told you the name of the destination callee name may be in terms of email ID, or it might be any mnemonic. Okay, so that can be converted into IP address. For this, the user moves around and find out, or otherwise a DHCP protocol might be used. DHCP stands for Dynamic Host Configuration Protocol, which will resolve the IP address. And user has different IP devices. That is also possible. So one might be having the PC, other is smartphone, or the any other car devices. This is how the translation is performed here. Okay. Then it comes to the result can be based on the time and day. See at what time they are doing. I think there are certain decisions to be taken on the basis of that either on the based of time and the location. So if they are in the working place, fine, or if they are at the home, then how whether to transfer the call or to fix the call, all that can be taken decision. The caller don't want to call boss at home, so that is why depending on the status of this one, whether he is at home or the work, he will take a decision to call. Status of callee is also very important. Call sent over voicemail when callee is already talking to someone. Okay, so there are possibility that the callee might have been engaged at this point. This engagement lead to a problem to the caller. The caller may send either a message or a voice message, text or voice message. Okay, so this is also possible. All these are on the basis of the location of the person. The decisions are taken for the particular communication. Then there is a registrar. I think this registrar is the function of SIP server, and you can see that registration of particular SIP with the registrar is essential. You can see the person who is really handling, because in the domain, in the given domain, when you are trying to make a communication from one client to the another client, you can resolve the address through this registrar. So the registrar's job is to take the registration of all the clients in the network. Okay, so the moment any request comes, it will resolve the address and it will redirect the call to the destination, because the registrar will have all such information. and the registration is done by SIP register. You can see that the register, SIP domain and other details via SIP protocol. Okay, again the from address is given, to address is given, and the expiry time is also indicated here. Okay, another an important component of your SIP communication is SIP proxy. The proxy is always at the gateway point. Okay, you see that this is the domain or the cloud. Okay, you want to make a communication with one person, you are here in another domain. Okay, and there will be a proxy. This proxy will help you to find out, connect to the network. Through the proxy only you will be connecting to the registrar. Through the register you find the destination. So different hierarchy of communication is possible. That is why SIP will have a registrar, and this register is local register is called as proxy. Okay, so Ally sends invite for message to the proxy server. Very first request from any domain goes to the proxy. Okay, the proxy is responsible routing the SIP message to calling. That's what it will go to the registrar, collect the information, and then it will forward to the calling. Bob sends response to back to the same set of proxies. Here, one thing what you can observe here is the response from Bob will come back to the proxy. Through him, it will be connected to the client. Okay, so SIP proxy is analogous to the local DNS. That's what I told you. You see an example which will explain you how exactly this will work in this system. Okay. There are two clients which are connected with a proxy server register. Number of registers are there. You see the person at this point wants to make communication with this person. He doesn't know his IP address. He will send the request with an invitation, and he has sent a mnemonic address of the destination UMAS, and it is sent to the SIP proxy. Here it is the SIP proxy UMAS. From there, the request is forwarded to the register by the proxy. The proxy will forward this request to the registrar. Okay. Once the registrar is received, he will understand where the destination or callee is available. For him, who is the registrar? All this is known to him. So he will forward saying that you please contact the Kenneth Uranum register. So the call forwarded to this register, and he in turn will find the Keith is the destination or callee from the caller. Here is the caller, and this is the callee. Okay. After that, this is responded back to this saying that an agreement is happened between the callee and caller about the discussion or transmission of particular files or applications. Now the complete communication goes like this from here to here. So this is the data flow. Finally, again, termination is also started from here, and after completion of the complete transmission, and that will be reached the caller, and finally it is terminated. This is how exactly the complete SIP application will work. It's a wonderful technology, and you believe it or not, any one of you who are really interested in designing such protocol, it is an inspiration for you, because you know the way you these protocols are designed are explained in a beautiful way, and with a proper reason for each of these segments and operations of these protocols, so that you can definitely think about these protocol, you can identify what are the drawbacks in it. You can overcome that by your own idea. Okay, so then you become the person to develop your own protocol, which can be definitely utilized by the people in the future days. With this, I wish to conclude my session at this point. I'm very happy that these two protocols, RTP and SIP, are really very helpful for the real-time applications to run and effectively in the network. So in the next class, we will discuss on the network support for multimedia. So I think we have to go to the depth of the network and understand how the network is designed to support the multimedia, because multimedia is a unique application that to run in the network. With this, I conclude my session at this point. Thank you very much.